Alright, so before I start going over the WebAssign questions, or the similar WebAssign questions, I wanted to point out that when you print out your notes for section 2.3, you also get the odd problems completely worked out. Question 1, 3, 5, 7, 9, all the way through to question 43. So if you really want to learn the material as well as possible, I recommend you look at the odd exercises as well. So let's look at the first one. They say given the limit of f, all these guys as x approaches 2. The limit of f is 4, the limit of g is minus 2, and the limit of h is 0. Find these two limits. Well, the limit of f plus 5g is just the limit of f plus 5 times the limit of g. Well, we know f is 4, and we know g is negative 2, and that's 5 times negative 2, and that gives you negative 6. On this one, the limit of g to the third power is the third power of the limit of g, which we know the limit of g is negative 2. Cubing it, you get minus 8. Alright, the limit of the square root of f is the square root of the limit of f, and we know the limit of f is 4, and square root of 4 is 2. The limit of 3f over g is 3 times the limit of f over the limit of g. We know that's 4, that's negative 2. Reduce it, and we get negative 6. E, the limit of g over the limit of g over h, that does not exist because the limit of h is going to be 0. You can't divide by 0. Now here with this one, this is the limit of g times the limit of h over the limit of f. Well, we know g is minus 2, h is 0, f is 4. You get all these values and you get 0. Question 2, they ask you for f plus g, pretty much the same sort of thing, but they give you a chart. They don't tell you what f and g are. So first one says the limit of f plus g equals the limit of f plus the limit of g. So you got to figure what's happening at 2. So at x equals 2, f approaches minus 1, and at 2, g approaches 2. So minus 1 plus 2, when you plug them in direct substitution, you get 1. The limit of f subtract g equals the limit of f subtract the limit of g, but that does not exist when you approach 0 because the limit of g does not exist at 0. The limit of f times g equals the limit of f times the limit of g at minus 1. At minus 1 you're approaching 1, and here you're approaching 2, so it's 1 times 2 is 2. The limit of f over g at 3 you're approaching 1 here, and at 3 you're approaching 0 here. So this one is not going to exist because your denominator's limit is 0. On this one, the limit of x squared f is the limit of x squared times the limit of f, and the limit of x squared is just 2 squared. The limit of f is at 2 is minus 1, so you get negative 4. And f of negative 1 is defined at 1, 2, 3, 4. F of negative 1 equals 3, sorry. And the limit as x approaches minus 1 of g is 2, and so that one is just 3 plus 2 equals 5. Number 6, the limit of this fraction equals the limit of the top over the limit of the bottom. You can take each one separately. Then you're finally able to do direct substitution, and you get an answer. Same thing here, the limit of the square root of this guy equals the square root of each of those terms, and then you're able to do direct substitution and simplify. The limit of these two numbers, these things multiplied together, equals the limit of each one, and each one you can break it up individually, and then you finally are able to do direct substitution with that one, direct substitution with that one, and you multiply it all out and you get 18. Limit of this guy is the limit of this guy cubed equals the limit of this fraction raised to the third power, which is the limit of the top over the limit of the bottom, which is the limit of each term, all raised to the third power, which you can finally at that point do direct substitution and you simplify. Now they say, what's wrong with this equation? This guy equals that. Well, the left side is not defined at 2, but the right side is defined at 2. In part A, explain why the equation, the limit, equals that. Well, we don't care what happens at 2 since we're approaching 2. So you can say the limit of this left-hand side equals the limit of the right-hand side. Now, there's a whole bunch of problems here let's go through them. These basically you factor and cancel and then do direct substitution. You factor and cancel and do direct substitution. You factor and cancel and do direct substitution. Here you just multiply this guy out and simplify, and then you're finally able to do direct substitution. Here you factor it, cancel, and now you're able to do direct substitution. Here you got to multiply that guy out, cancel your 9's, divide by h, and now you're able to do direct substitution. On this one, since you've got a complex fraction, a fraction within fractions, it's a simple way of getting rid of your complexity is to multiply by a common denominator, in this case 3x. 3x times 1 over x is just 3. 3x times 1 over 3 is just x. And in the bottom you still get the 3 and the x, but you also have the x minus 3 that was originally there. So now you can cancel a 3 minus x with the x minus 3 and replace it with a negative 1. X minus 3 and 3 minus x are factors that differ by a negative 1. So if you cancel them, replace it with a negative 1. Direct substitution gives you an answer. Alright, this one, if you write this as one big fraction, takes a little bit of work, but you finally have one big fraction. You can cancel your t's, and now you can do direct substitution. This one, you want to rationalize the numerator by multiplying by its conjugate, 4 plus the square root of x, top and bottom. When you do that, you can cancel a 16 minus x, top and bottom, and now you can use direct substitution and you get 1 over 128. 43. Find the limit of this guy. Well, f, if you call f the absolute value of x plus 4, that means x plus 4 equals x plus 4 if x plus 4 is greater than 0 or equal to 0, and negative x plus 4 if x plus 4 is less than 0. Now what does that mean? That means if x is greater than negative 4. If you move this 4 over, you can say it's the same thing, but just a rewrite of this inequality. Same thing here is a rewrite of the inequality. So now you can see the interesting part that's happening here is at negative 4, which is the one place they ask you to take the limit of. So as you approach this negative 4 from the right, greater than negative 4, you're going to use x plus 4. In place of absolute value x plus 4, you're going to put in x plus 4. And that reduces, and you can do direct substitution, and you get your answer. Coming at negative 4 from the left, you're going to be using this one. And so you replace this absolute value with what it equals, this right here. And when you simplify, you get this, and now you can do direct substitution. The fact that the left and right hand limits are equal tells you that the limit exists and it equals 8. There's two more problems here. This one says find the limit as x approaches 1 from the left, from the right, and then asks you what does it look like, and then they ask you to sketch it. So here from 1 from the left, you're talking about less than 1, so you're taking the limit of this guy here. Okay, the limit from the left is x squared plus 1, and direct substitution gives you a 2. Now the limit from the right, you're going to be using numbers greater than 1, you're using this guy here. So in place of f, you replace that guy there, and now you can do direct substitution and you get 1. Now the right hand and left limits at x equals 1 are not equal, so the limit does not exist. And what does this graph look like? It looks like this, and you can clearly see at 1 it does not have a limit. 54, they ask you the limit at 1 and 2, but they ask you left side limit, and then at limit at 1, and then finding what g of 1 is. If you graph it, it looks like this guy here. So first thing, what's the limit as x approaches 1 from the left of g of x? 1 from the left, you're talking about this value here, which is just the limit of x, and you can do direct substitution and you get a 1. Now 1 from the right, you're talking about greater than 1, so it's 2 minus x squared you're replacing, and you can do direct substitution and you get 1. Now since the limit as x approaches 1 from the left equals 1, the limit as x approaches 1 from the right equals 1, we can say the limit actually exists. Note that g of 1 equals 3 does not affect our value of our limit. So number 3, when x equals 1, g of x equals 3, so g of 1 equals 3. Now they ask you the limit as x approaches 2 from the left, 2 from the right, and at the point. Alright, so 2 from the left you're going to be using numbers smaller than 2, so you're going to use 2 minus x squared. And you can do direct substitution and you get negative 2. Now 2 from the right, you're going to use greater than 2, so you're going to use x minus 3 in place of g. And then you can do direct substitution and you get minus 1. So the limit at 2 does not exist because the limit from the left and the right do not agree. Then they also ask you to sketch the graph, and that's what the graph looks like.